There are three states of matter that an element can go through. It can become a solid, liquid, or gas. The element fluorine in its natural state is a gas because it is a diatomic element. For every element in the periodic table, there are three subatomic particles that make up its structure. They are known as protons, electrons, and neutrons. Fluorine contains 9 electrons and protons. In order to calculate the number of neutrons, you have to take the atomic mass of fluorine, which is 19 AMUs, and subtract the number of protons to get 10 neutrons. When combining with other elements, fluorine will become a fluoride ion. For example, if it were to combine with calcium, it would become calcium fluoride. This would be creating an ionic bond. The calcium here is known as a cation, meaning it carries a positive charge of 2+ and gives away 2 electrons. If it were to create a covalent bond, meaning it reacts with another non-metal like boron, it would become boron trifluoride. The fluoride and boron are both anions, meaning they carry a negative charge. Usually, fluorine ions carry a charge of -1, meaning it gains an electron. In this case, fluorine gains 3 electrons while boron gains 1 electron. Not only are the halogens the most reactive group out of the entire periodic table, most of the halogens are diatomic elements as well. Fluorine is the first to appear in the group and is also the most reactive. The entire halogen family gains 1 electron, meaning they are all anions. This group is the closest group to the noble gases. Since fluorine and chlorine are in the same family, they share the most similar chemical properties. Being from the halogen family, this also means that fluorine's oxidation state is -1. Because it is such a strong oxidizing agent, fluorine causes many substances to ignite when they come into contact. In this equation, fluorine is the reduced species since it starts off with an oxidation state of 0, then becomes -1. This would also mean that this is the oxidizing agent as well. Being in the halogen family also explains how many valence electrons there are. The group is right next to the noble gases that contain 8 electrons, meaning that the halogens contain 7 electrons. The Lewis dot structure shows this by having 7 dots around the element symbol. This example, the 7th valence electron is shared with hydrogen. The electron configuration of fluorine are shown here. In order to calculate the quantum number of fluorine, you will look to the last orbital, which is 2p5. The principal quantum number is 2, the angular momentum is 1, the magnetic quantum is 0, and the electron spin is -1/2. The Vesper's theory states that each electron group form electron geometry around a central atom, causing them to become stable and minimize the repulsion between the electrons. Looking at beryllium fluoride, beryllium is the central element, meaning that fluorine would be on either side of beryllium in order to repulse each other. This would mean that beryllium fluoride would create a linear molecule, creating a 180-degree angle. Here are some fun facts about fluorine. It is often added to toothpaste and water supplies in order to prevent tooth decay. The first large production of fluorine was during World War II in order to create the atomic bomb Manhattan Project. Hydrofluoric acid is used to etch the glass of light bulbs. Fluorine is the 13th common element in the Earth's crust, and the cost of pure fluorine is $190 per 100 grams. Using this reaction, specify which species are being oxidized and reduced, and then specify which is being the oxidizing agent and reducing agent.